Alright, in this video we're mainly going to talk about domain and vertical asymptotes of a rational function. Alright, so a rational function is defined as a function where you have a function divided by another function. Alright, so that's what we're talking about when we're talking about a rational function. So here's an example of that. Alright, here's this graph right here, alright, graph of this function. And it says the domain of the rational function includes all the real numbers except the x values that make the denominator equal to 0. So that's important. So it says the domain can be essentially determined. It can be any number except for when you set this denominator equal to 0, right? So it says what would make this denominator 0? Well, all we have to do really is just set the denominator equal to 0 and then solve for it. If I subtract 2 from each side, that tells me right there that x is equal to -2 would make the denominator 0. And that tells you two things, okay? What it tells you is if whatever makes the denominator 0 actually makes your vertical asymptote. So what that means, and we have talked about this in the past, this right here is a vertical asymptote at x is equal to -2, which is a vertical line. Remember, x is equal to -2 is a vertical line. So therefore, what are my vertical asymptotes? Well, it's what my denominator, remember, my denominator equals to 0. So therefore, in this case, that's x is equal to -2. That's something we already talked about in the past. So, alright. On this one, alright, if they have some kind of matching, and I'm going to have a little trouble here because I don't have enough screen. I can't really zoom out for you to be able to see all those. Right, they're asking you to match the graphs to the rational functions. Well, this is going to be easy because if I know my vertical asymptotes, and I can figure that out pretty quick, right? So if I set the denominator equal to 0 on this one, oh, look at that. It looks like my vertical asymptote at x is equal to 0. This one does not have a vertical asymptote of 0. This one does. And this one doesn't. Alright, now again, a vertical asymptote would be a vertical line that the function cannot go through, right? So it's also happens to be part of your domain. Alright, so therefore this one right here is going to be matched up with graph number 2. Let's look at this one. This one's kind of nice because the denominator is already factored for you. So if I set each factor equal to 0 and solve, then I can figure out what my vertical asymptotes are. In this case, I have two vertical asymptotes, one at -3, one at +2. So therefore, I have two vertical asymptotes. Okay, on this one. So this one's actually 3. Alright, last but not least, well, I guess you can do this by process of elimination, but notice that this one, if I set the denominator, only the denominator equal to 0, I would get x is equal to 1, which in this case is, this one's a little bit harder to see, I think, but yeah, normally the function gets really, really close to that vertical asymptote without actually touching it or crossing it. Alright, so let's go ahead and talk about these. Right? So it turns out that knowing what I told you, if you know the denominator, where the denominator is equal to 0, that tells you both your domain and your vertical asymptotes. Alright, so again, if I set this denominator equal to 0, I get that x is equal to -2, and this is where my vertical asymptotes are located. And where my vertical asymptotes are located, it turns out to be the only place that's not defined in the domain. So notice that I'm writing the domain is all real numbers except for x cannot be equal to -2. Okay? Now, that's pretty much all there is to this one. So let's look at number 5. Number 5, same idea. We're going to set the denominator equal to 0, and then notice that on this one I have a difference of squares. So I can factor this, and I get 2, after I set each factor equal to 0, I get 2 answers. Okay, that's one way to do it. Also, if you wanted to, you could have added that 4 to the right side and then taken the square root. The main mistakes that students make normally at this age is that they forget to put a plus or minus. Notice it's the same answer, right? -2, +2, positive, negative. So either way works. Alright, so again, that tells me that my vertical asymptotes are located at x is equal to +or -2. And my domain is all real numbers except for x cannot be equal to positive and negative 2, right? Okay. Let's go on. On number 6, I have x squared is equal to 0. Some of you probably already know what this is or how to solve for that, or what it is without solving for it, but yes, take the square root of 0 is still 0. So my vertical asymptotes are going to be located at x is equal to 0, which means that my domain is all real numbers except for x cannot be equal to 0. Okay. So all of these really just become an exercise in either can you factor, and that's pretty much it, assuming that you kind of got this down, right? If I set this equal to 0, remember I have a common factor of x, so I have two answers. X is equal to 0, x is equal to negative 3. Alright, so those are my two answers. So my vertical asymptotes are located at x is equal to 0, x is equal to negative 3. And my domain would be all real numbers except for x cannot be equal to 0 or negative 3. You can write it like that. On this bottom one, set that equal to 0. Why don't you go ahead and factor that yourself, but if you do it right, you get the two answers would be vertical asymptotes would be both of those, and my domain, well, all real numbers except for x cannot be equal to negative 1 or negative 3. Alright, finally I'll read this one just for the sake of the factoring part. Alright, if you're doing this factoring, again, well, go ahead and put that x cannot be equal, oops, forgot to put that up here. Okay, so we're going to set this equal to 0. And now we're going to go ahead and do bottoms up, even though this one is not too tough, because the only factor of 2 is 2, the only factor of 3 is 3. So, we're going to multiply those two together, so we have x squared minus 5x minus 6 is equal to 0, so I have two factors, one is negative 6, the other one's positive 1. And you're going to set each factor equal to 0. So x is equal to 6 and x is equal to negative 1. That's what would make the denominator 0, and if it makes the denominator 0, that's where your vertical asymptotes are located. Oh, you know what? I forgot one thing that I always tell you guys is like, hey, most students always forget this. Well, I just forgot it. Before I do even this step, alright, the thing about bottoms up that I myself forget is that after you've found your factors, you need to divide each one of these by this leading coefficient. So this would be x minus 3. This one cannot be factored or reduced anymore. Reduce it if you can. Bring that 2 up by the x. So we have 2x plus 1 is equal to 0. So, sorry, the answers are x is equal to 3 and x is equal to negative 1/2. Alright, remember, subtract the 1 divided by 2. Alright. And the same idea here. X cannot be equal to 3 or negative 1/2. Alright. So that's that for that part. So I'll make another video for the next section, which is a little bit more involved, but hopefully you found this relatively simple.